Dr. P here. Today we're going to talk about work. And I don't mean like, hey, I go to work or, oh, I went and did my workout at the gym. I'm talking about physics work today. So the physics work is the transfer of energy from one object or a system to another object or another system through a mechanical process. This idea of a mechanical process is basically just like applying a force. And so this happens obviously when a force is exerted on an object or a system along the direction of motion as that system or that object moves. And so let's say I have a box. That box moves along this surface. If I'm going to pull on the box and that box travels a distance d, then the work that is done is going to be equal to the force that I applied. The work on the box by this force is going to be equal to the force that I apply on the box times the distance that the box travels. Now, this idea is along the direction of motion is important because if I were to change the angle of this force so that this angle, let's just say, is theta, all of this force now is not applied along the direction of motion, the x direction, and so I need to take that into account when I calculate the work. So the work is really the force parallel to the distance, or most oftentimes you might see it as work equals the force times the distance times the cosine of theta, where this angle is the angle between the direction of travel and the force. If I were to create a graph of the force applied on an object over the distance that object is traveling, we'll write it as x, and maybe that force goes like this, up and down, or it might be constant. The area under this position, this force versus distance, is going to be the work. Area is work on a force versus displacement graph. There are ways that we can describe forces. We can describe them as contact forces versus non-contact forces, meaning like touching each other. Gravity is a non-contact force. Friction is a contact force. We can also talk about forces as being conservative or non-conservative. Now, when you have a conservative force, the work only depends on the initial and final positions. We could call this path independent. Meaning if I were to lift a box in the air to this second height, I could talk about the work that's done on the box by my arm as I lift it up. If I were to take a different path, let's call this path 1 and this path 2, that initial position and that final position, the work done by gravity will be the same for both of these paths. Gravity is the prime example of a conservative force. Another conservative force would be the elastic force. Remember the elastic force, we haven't really talked about this much yet, but that F elastic force is negative kx. Non-conservative forces are also known as dissipative forces. These forces depend on the path, or they are path dependent. The biggest non-conservative force would be friction, and anything sort of friction related like air resistance or drag. You could imagine that if I took path 1 and I were to move a block across the table just from here to here, I would lose a certain amount of energy. But if I were to take that same block and I were to rub it across the table horizontally as I go across, and then I reach my next point, that I will lose more energy when I make a longer path.